Hello and welcome to the tutorial where I would like to simply show a project workflow, that is, a process. This means that you will also see me in the video. In the back you can also see my printer where I print my stuff in HiCAD, and I just want to start a project now and simply show this process. Basically, I naturally start in HiCAD in combination with HELiOS with a new project. That means I enter a new project here. Of course, I need to assign a project number to this project. In this case, I simply choose the project number 4121. This means that this project number was assigned to me by my ERP system. I can still specify here in which project folder I want to have it. In this case, I want to place it in my project folder webinars. This can of course be divided into projects 2021, projects 2022, or by the customer. So in my project mask, which can of course be customized, I have defined my predefinitions, meaning they can also be modified or expanded as needed. Of course, I can also store customers here and enter them as well. With OK, this project was created for me. Basically, I want to start a new design here, which means I am creating a new design. Here I get the article mask, which is totally nonsensical or not useful for me at the first step. That means the article is automatically assigned to me by HiCAD. I would like to enter certain values here in the document mask, meaning I want to define a positioning here. I would like to simply have my 3D model saved as the designation here. So now, as usual, my article mask comes up, so parts, attributes, mask, that's how I should say it. And here I want to define my overall model. So that means I have now created my new design. You can see from the green cylinder that it is also saved, and I would like to start now. How does such a project proceed? Basically, one has to imagine that either I have to draw my natural dimensions, or I receive an IFC file, or I receive a DXF or DWG on which I can build. In this case, I received a point cloud from the customer. So thanks for the point cloud. I got a point cloud from the customer Gruberhofer, from the district, from the state of Salzburg. And I would like to load this point cloud here. That means I can import it directly here using the point cloud module. That means I simply have to go to the folder where I have stored this point cloud. It is located here in this folder. And now this point cloud will be placed into the design. First, I am asked for an orientation here. This means it is important for me now that I want to design in this area. This means I have received certain requirements from the customer, which we will go through later. That means I will align the point cloud with this surface. So basically, you can see here that this point cloud encompasses much more, and I only want to work in this small area. That means in this case, I will simply use the clipping box to edit and reduce the things that are not necessary for me in 2021. That means I can either go to the points or the arrows here and move the clipping box in various directions. So basically, I also have the option here. Personally, I prefer working with the arrows, but of course, that's a matter of taste, and I can simply reduce the height of these clipping points. Here. So, let's take a look at what I have here. I will make this clipping box smaller now, because there is actually a lot inside that doesn't concern me at all in this case. So now, my clipping box has been reduced to approximately the area I need. Actually, I just noticed that I want this area to be a bit larger. So, this is my point cloud. When you zoom in, you can see, of course, that there are many individual points here, which I can also use for the design in further steps. 2001, of course, just like in other videos I've already mentioned, structure is everything. That means I would like to continue building this structure here. That means I want to create a structural assembly here where I can place my point cloud to make it easier to show and hide it later on. So basically, I have now received the following task for this construction site. That means the customer wants a railing here, a wall handrail on the back side, and a carport. In other words, some kind of small shelter. And I would like to go through this with you a bit here to see how one could work with it. As I said, structure is everything. That means I want to have my further structures here. Now, there is my railing as a structure, which was requested by the customer, and there is also the canopy or the roof. Let's call it a canopy, where we can basically start constructing here. So I will start here with the railing in the first step. That means I want to build this terrain here. In steel construction, there is typically the railing along the edges. For this, I need to draw an edge here. I would define this using a 3D sketch. That means I simply specify a surface here and can capture these points here. Basically, when I zoom in here, you can actually see a lot of points. With the C key, I can directly select these points using the quick selection and also construct within here. I take my points here, which I can select here. That means you have to look here. In this case, I want to have this point here so that I have my path here. Of course, I can continue to edit these lines normally with the functions. For example, here, I want to extend it to this surface. You can see here in this case, I have obviously chosen this polyline incorrectly. I will now delete this polyline again. So you should definitely make sure to capture the points accurately here. This didn't happen to me like that, but of course it can always occur. That's why I will now pay a bit more attention to which point I hit. And here you can see it very well when rotating. I hit this point correctly. So now I want to extend this line just like before. It should go up to this surface, and I want to use this line here. Since I know that I also want a line at the back, in this case, I can copy this sketch right away with the right mouse button. I simply select the end point of this edge right here and just want to copy it to this edge here. Of course, I need to look further here because I have already looked at the point cloud. Here you can also see a small ledge where the full thermal insulation is applied. I must then, of course, take that into account with my values, or I extend or shift this edge. Now I select my connection here, which means railing along the edge. First, as usual, I need to read the bottom left. I can select the edge here, and I see that. The Z-axis is always used for my railing. You can see here that I didn't pay attention to where the Z-axis is going. Therefore, I need to cancel this command again. 2001. I can switch the world coordinate system here with the W key, or here with the right mouse button, and I want to select the W edge again here. The selection is completed with the middle mouse button, and then my dialog is started here. So, in the dialog, you can now see the various possibilities. I have, of course, the different favorites here that I can select as options. I have simply set a favorite here. In this case, it is just about the fact that the offset is already set here. And at the same time, the connection of the substructure for the posts is also set. Basically, I have just slightly reduced the values from the standard. I can set the fillings here, which means I can easily adjust to glass filling, bottom rail with frame, or whatever else. What transition do I want here for the connection to the spindle? So, I want to have a connection with the spindle at the top to the handrail here. And with OK. I can simply install this here and just check what I have basically set up here. So this means here you can see my railing. It was created here. You can also clearly see here that my posts might not be in the right places where I would expect them to be. That's why I simply go back into the railing configurator with a double click on the feature. And here under post distribution, I have the option to create an individual post distribution. That means I just click on it. Here, the posts are displayed to me, and depending on which green or dark green frame I hover over, I see a preview in the graphic of which post it would be. That means I am focusing on this post here. I'll take a look at this. Where do I want to place my railing post in this case? I want to move this railing post to a point here on this support slightly. And I can then look at this and select the center point of these again with the key C. So of course, select the correct one. This center point approximately, roughly, of this step 2001, essentially, basically. This post would fit here. I might need to pull this one down as well. That would basically have the same effect, or I could also work with values here, of course. That means if I go here and say, for example, I want the last post to have a distance of 200 or 250. So then this will naturally be defined here by this edge length. So when I have made this division here, I close this command with OK. Now the railing is recalculated, the division is redone, the filling is redone, and my railing is immediately up to date again. So the railing has now been modified for me. Of course, I can also make changes at any time later on. For example, if I want to make a change somewhere. Pull this post down, pull the attachment down or up. In this case it would fit exactly, but I just want to show it demonstratively. Of course, I have the functions here where I can, for example, move points in a rectangle. Then I select the rectangle over the parts that I want to move. 2009 can use the middle mouse button to continue the command and specify the edge, and would like to simply move this down by 50 millimeters. This way I can easily change and correct the values. You can also see in the feature that these entries are confirmed there. This means that any changes I make afterwards will of course be carried over here as well. So the next step would be to attach the railing to the wall at the back. So as I mentioned earlier, I have an offset here, which means I will simply move this sketch to specify a second point in this direction. I want to shift this sketch by about 40 millimeters. Now I want to pull up the handrail. I can already see that the sketch is too short. But of course, it may be that I just want to show that I can do it beforehand, then change the sketch, and it will naturally be carried along with it. I see my preview again, where my posts and my wall handrail holders would be positioned, and here the configurator has also started. I can load a favorite here again, so to speak. Here I have the wall handler with a precast element. Now my favorites are being loaded, the settings are loaded, and you can already see the preview of where the parts would be placed. Of course, I have the option to further define this offset. However, I will simply implement it first to see where I stand, and then I can change the values. So, I probably need to change the values here. That means I can also directly select the preview, and it will simply be incorporated here. Of course, I don't have to restart the dialog every time to see what I have set. So, you can simply see here that these values would be fully inside the wall. That means I simply go to the offset here, and then 100 would just be the value. Then you can see here, okay, I am on this line, can click on the preview again and see my effect, what I would have set here. Now let's take a closer look at this. You can see here that my wall handrail holder is now mounted on the wall with a precast bracket 2001. Of course, I can also define additional versions here, such as custom manufacturing, whatever I need. I just want to look at the values. Here, I have various values that I can also adjust. I will simply load or leave it finished here and want to install this wall handrail with OK. Gather 1,000 people and rise to the occasion, making sure everyone is ready and prepared for the challenge ahead. As it naturally happens very often, I have now forgotten to pay attention to how long my line is. That means I naturally want my wall handrail to go further up here. I can modify the line here at any time, and I want to extend this line up to this surface. I can also update the wall handrail at any time, and it should now be updated, meaning recalculated. And now I can check how this will fit together with the natural mast in this case. That means if the wall handrail is in the air or not, how can it still be attached? What has it seen now? He then pulled it, it would naturally fit here as well. Of course, I can also perform the check here again. That means I can naturally go ahead and look at a side view, and I am now deliberately switching to the hidden line mode to simply see where these handrail parts are located. They are now, in terms of height, I would say, on the same plane, which means it fits, and I will leave it like that. So, now, to make sure the structure fits, I take these parts and put them into the railing structural assembly. Then I can give this plan to the customer and ask if it fits or not. I can also change the values at any time and possibly install a different railing, whatever is needed. So, in the next step, I would like to try installing a small cardboard or a small canopy here to show how I can adopt parts, edges, or surfaces from the point cloud. In the point cloud module, there is the possibility to define a flat point cloud. I want to align these parallel to a surface. I want to create a vertical surface and a horizontal surface here. I can mark points on the plane at the top of this level. You can see here what the maximum deviation is in this case. That means I have a maximum deviation of 4 millimeters over this length and an average of 2.5 millimeters. This means the surface on top is actually quite flat. This way, I have simply created a plane, nothing else. I can now build upon this plane in principle, which means I will just switch to the top view here and can take my profiles from my standard parts library. That means I simply want to insert an HEA here. So I take an IPE on top, IPE 180, place it over 2 points. And in the first step, I just say that it will be installed vertically, or in this case, vertically in the drawing plane. So, as you have already seen, when I switch to hidden line, the point cloud is not displayed. I could also add auxiliary lines with the H key. That means I simply want an auxiliary line here because this beam, they should have a certain distance from my railing. That means I want this first beam to be approximately 200, not approximately, but exactly 200 millimeter away from the handrail, from the edge of the handrail. That means I simply shifted it here very easily. I can now switch back to my top view because my first beam is already completely and thoroughly defined. I can easily push this beam downwards from here in terms of height and stability. That means with the right mouse button, I select an edge here and say this should now simply be moved down by 250 millimeters from this top edge, that is in relation to the axis. These beams belong to my roof. I want to create a new structure here where I can pull in my roof to keep it clean and also make it easier to modify. As you will see later, it will also make it easier to show and hide the parts. So my first beam is roughly defined in its basic form, approximately. Now I want this beam to occur more frequently, which is naturally often the case. I want to copy this parametrically here. For this, I select this mode here And first, I simply need to specify an axis. I want to copy this profile in this direction. You can already see a very simple preview here. I can change the values at any time, such as the width or length to which it should be copied, and how many times it should be copied. I can of course change this at any time. A feature is also being created for me here in another respect. 1000, I also only want to copy one-sided here, otherwise it would be backwards. In principle, I say OK, and you can see here that it was copied. Through this copying process, a feature was created for me on the parent part. I can modify this feature again with a double click and could also change the size at any time. And of course, the quantity. With OK, I will leave my entry here. So now I just want to define the inclination. You can clearly see here that a little figure has also been scanned. That means I have a reference here right away. I could also define the height dimensions here and measure out the parts, but I see it very nicely here. I want to create a slope here, meaning I want to select this roof and assign a slope along this edge. I say in this case it should be 5 degrees, which means it will be rotated forward by 5 degrees. And I also want to have vertical profiles here. For this, I go back to the steel construction section and select my profile groups here. In this case, I would like to have an HEA here, so I am selecting an HEA 180. If the statics might not be quite right, since we don't know where it stands, which means it could be, I can of course change it at any time. We will naturally do that as well. However, I want to have a point perpendicular to the processing plane here, and I want to have a beam at the very end here and here, at the beginning and the end. Those should be my supports. Of course, I will also immediately give them a proper name. So I just noticed that I selected an HR. That is definitely too weak for my statics. Just move it downward slowly. So now I have successfully caught the individual one. That means I have just clearly defined the rough representation. Of course, I can also work with visibilities here in HiCAD. Here, for example, I want to display this steel framework. To do this, I can go ahead and say, for example, I only want to see this canopy, and everything else should be hidden. So I haven't added that yet, which is why it isn't included, but I will also display these supports here. Replacing is of course very easy in HiCAD. Right-click on the part to replace it via a reference. I have various options for how I can replace it. I simply want to replace the molded part here and select an HR. And in this case, the center of gravity should remain the same. So now I would simply like to have a horizontal profile. For this, I would simply like to select a profile here. I am taking an eBay here again. I am taking one here. And I can also install it three-dimensionally. So simply from this point to that point, now it is positioned more vertically. But how can I define it correctly now and bring it into the right position? So personally, I would simply do it by creating a sectional view here. For this, I create my sectional view here at USAND. This should essentially run vertically, display the parts behind it. And with OK, this section is generated for me here. And now I can definitely and clearly see where I am working with my parts. It could of course be the case that all these different profiles, each and every one of them, are involved. This means that every single profile, without exception, might be part of the scenario we are considering. We need to take into account all possible profiles, ensuring that none are overlooked in our analysis. Yes, I will just do it all at once now, extending it simply. It would be easier now, of course, if I extend all of them at once here. That means I want to exit here, go to one of these profiles and say that in this case they should be extended by 250. Or of course I can also go ahead at any time and define them further at a certain point. But I still don't know where they should go. So I have it in the section. I could immediately place the profile in the right position here. I have to, or I would also like to represent my concrete wall here right away, because you can see that the point cloud is not displayed in the section. Therefore, in this case, I would remodel the back wall in the point cloud. That means I would model a part here to make it easier for me in the section and in other constructions. So I need a sketch here. I say it should now be freely chosen because I now, or should, let's try to make it a surface. That means I should be level with this surface, and I just select a few points. But now, based on this deviation, I see that I am actually quite level here. So 1 mm, which is basically almost nothing. Yusen can easily take the points. Here with my sketch functions, I take a polyline here and simply and easily select these specific points. In principle, for me, if at all, only the top ones, the upper edge, are important. The lower points are actually just for representing the wall in the background, in this case, clear. So, here another point, and with the right mouse button, I want to close this polyline here, and it has been closed for me here. By right-clicking again, I can create a part here, which will be revealed in the negative direction by 200. Of course, I could also exclude the window here, which I would like to quickly do now. That means I simply double-clicked on it, and now I just want to quickly exclude these two rectangles here. Once here, and once here. Basically says to take over, and this window was simply excluded for me here. So in principle, this also belongs to my point clouds. That is, point clouds and construction related matters. I can now hide the point cloud again because it often becomes distracting, but at least I can see my wall here, which makes it significantly easier to work in the section. That means here you can see the wall in section. I could, for example, go ahead and say that my support should and must have a certain distance from the wall. That means, in this case, I say I have a value of 4,500. The customer says he wants 350 menus because maybe only bicycles will be placed underneath. Now I have defined these vertical supports here. I see the parts here. Then of course I can very easily say, okay, the upper profiles should now stand a certain value above. That means in this case I am saying that the 500 should extend over the support profile. And now of course I need to bring this post to the right position. For this, the sectional view is naturally the simplest effect. So basically, I just move this profile, meaning this IB beam, to the middle of the beam. And now the simplest case is that I actually just have to make sure that this edge here is pushed down. And you can see how very easily I can define this in this particular section. So what is the next step? Of course, the rear profiles need to be cut at the back. Again, obviously, again. So, strap to the edge. I want to have 10 millimeter clearance here and at this edge. So, now I have basically already high cut these profiles here. In the section, I can only naturally, or maybe not. This could of course be due to the twisting. Here you can clearly see that they are not aligned. Of course I have to cut all the profiles to the surface here 2001. That means, of course, on the surface, where I cut these two edges as a surface. And thus, I actually have a shift cut of 5 degrees each here as well. That means you can see here, there is a 5 degrees twist included here as well. So, now, what is the next step? That means the beams, specifically the cross beams, are correct. The support beam is important. Now, we are still missing the supports. For this, I can of course always display the point cloud again, because naturally the beams need to have a certain length. I'll just say that they should be extended by 500 millimeter. Another 500, so they basically need to be brought to length now. And of course, there is the task at hand. In this case, it would be that we agree with the customer that the stones will be removed, a foundation will be made, and 100 millimeters should remain below the top edge. How could I do that now? That means I would shift this profile here, first go to the top edge of the stone, and then pull the beam down by approximately 100 millimeters or whatever is required. I do the same thing here by extending this beam to the top edge of the stones and then lowering it by 100 millimeters each time. So now I have basically defined this rough structure of the 2001 construction. What am I still missing? I could let these profiles on the left and right extend a bit more, which I will do here by 250 millimeters. Once here. And just once here. Of course, I could also work with the parts functions if I were to execute this. For example, as a static bending resistant joint. In this case, for example, the beam would be 8180 millimeters long. Of course, I could also define it as a fixed length and install it that way. So there are various ways to do it in principle. So to see the parts better again, when I create a connection here, I will hide the point cloud in this case to start a connection. That means I click on the end of the profile to easily see 2001 or to know that the connection comes on this side. Here, of course, there are various possibilities to define which end plate, meaning which sheet metal I want to use, and what sheet thickness. How should the overhangs of the sheet metal be? You can see them on the left, right, top, and bottom. The values are, I would say, rather secondary for me. The 2001, whether they are too big or too small, is irrelevant in this case. I can also set which dowel I want to use and the distance I want from the dowel. That means, as you can see here, for example, 50 is the inner distance. You can also see it here when I hover over it with the mouse, and here the distance is 50. So this whole spacing will definitely be 2001, which is way too small. But as I said, this is rather secondary for me now. Then the weld seams are, of course, important. I can certainly output those. Do I need backing plates, bases? I don't need any of that. I confirm this with OK. Of course, I can always open the feature again and recreate or modify it. Just like what I meant. This 50 millimeter distance is, of course, total nonsense. But for me, it is simply demonstrative in this case. With a double click, I get back to this connection. By copying, I can select an edge of the connection and have the option to bring it to the other connection. And since I am still in the copying process, I will go ahead and apply this connection to the rear beams as well. For now, they should just be screwed onto the back for me. Of course, you can immediately see here that with these settings I have made, this is absolutely not buildable. That means you can see the drill holes here. This is, of course, nonsense here. Therefore, I go back into the connection and simply change my values here, in this case from left and right, and the height, and thus I have a new one. So I naturally have to double click and can modify them, and they will then be further copied. So that means I give 50 millimeters each to the left and right from the drilling grid. If I have this inner distance here, I simply set it to 1 on 1. On the left and right, we should have 180. This means I have a distance of 160 here. This will naturally get a bit better here. The vertical distance is probably just a bit too small, but it is a bit very small. That means I will adjust the lateral distance once again. So here, of course, I can also directly specify a width, for example, width centered to the profile, whatever, so that I can have a straight line, a straight measurement, whatever. So now I have my connection 2001 here. To keep it simple, I will just copy this connection to the other profiles so that I also have my assemblies here. And furthermore, this is important for parts lists, drawings, and everything else that is needed. So basically, what am I still missing? Now the supports still need to be connected to the beams here. That means I also want to select the profiles again and can specify them here. Important. I repeat the same pattern with the stiffeners. Do I want stiffeners? If yes, which ones? What bolts do I want to use here? What dimensions? I can select these from the different bolt standards, the drilling pattern. That means I can define a vertical drilling grid here, and of course I can also measure distances here because I don't know the root dimension by heart. I can easily take it from here. Could also check if it is a load connection. In this case, I say okay, look at the connection. If it fits 2001, then I leave it. Otherwise, I change it again. That actually looks quite good. And in this case, I will copy this connection to the second side. So, once you have a bit of practice, you can of course also do this for small tasks directly at the customer's site. But of course, a bit of practice is necessary. Personally, I probably wouldn't do it either, because then more and more ideas come up and you have to deal with these topics much more and make the changes. So usually, when it is finished, you give them a PDF and then go through the things. So, I would like to add a connection at the top for the purlins. That means I simply take a purlin connection, select the purlin, select the beam, and can then set the values here. Which bolts do I want? Which stiffeners do I want? Do I want another one on the purlin? Do I want to have a stiffener on the purlin? Let's just see if I want it. Of course, I only have the purlin stiffener on one side now, so it should be a full stiffener, which is essential for structural integrity. Yes, that's a good question, because it addresses a common concern. So, install it precisely in the middle of the front side, ensuring it is aligned correctly. Now I'm completely over it, and by that I mean that I have decided to leave them out entirely. This process involves copying the necessary parts, just like this. As you can see, I've managed to accomplish quite a lot in a relatively short amount of time. To elaborate further, this method has proven to be highly efficient and effective. By focusing on the essential elements and disregarding the unnecessary ones, I have streamlined my workflow significantly. This approach not only saves time, but also enhances the overall quality of the work. For instance, when I encounter redundant information, I simply omit it and concentrate on the core aspects. This strategy has allowed me to achieve my goals more swiftly and with greater precision. In summary, by adopting this technique, I have been able to maximize productivity and minimize wasted effort. Of course, I haven't done anything with edge sheets now. I can, of course, add cladding sheets in the sections, but I haven't done much of that at the moment. In this case, I am aware of that. What I am really more concerned with here is that I was able to create a workflow for 2001 and demonstrate it, and now, of course, I can ask, how do we proceed? That basically means, in the next step, I would do a search for identical parts, which of course took a long time until I had something. Through this search for identical parts, I can then define which parts are the same, what fits together, what do I have. This is also important for bills of materials and the like. That means when I have now done the search for identical parts, you can see it here by the numbers that have already been assigned, which parts are identical, which position numbers are the same, whatever, that I have the parts here. I have already completed the construction here and I am currently saving it. I want to generate a bill of materials and have it output directly as an Excel file. That means in Excel, since everyone is most familiar with it, all data is output in Excel and the customer can more easily adjust everything in this case, because actually Excel allows someone to make changes relatively quickly. Here you can simply see a structure list where the assemblies are summarized, a quantity list where everything runs down in one go, then the profile summary list where the profiles are summed up, how the parts need to be cut with the position numbers and the like. We don't have any edge sheets now. We also don't have any grading now. Then my screw list. That means I would also have a screw list here. I just see the number here. They are a bit strange because I set the position number to something very high, which I actually didn't want to have. A shipping list, where I also have the pictures of the respective parts, a shipping list briefly with the individual parts 2001, then here only the pictures. Further, then the profile bar list, which would simply be the profile bar optimization of the individual profiles, and here the summary. That means here the last column, I can very easily see what I have actually designed here. What do I need to order? And here I have a really nice way to check what I have designed and how heavy it is. That means I now have a ton, and I can roughly calculate what I need to produce and what I need to offer. So, what am I still missing? The drawings. Drawings are also a big topic. Everyone wants the drawings to be different. I just click on it. I use my settings. I want the drawings to be defined in such a way that I have individual parts on one plan. Of course, there are various possibilities. One person says, I put many parts on a plan. One person says, I only want I-beams on a plan, I only want pre-drilled parts on a plan, or I want individual parts on a plan. There are, of course, many ways I can define this. Personally, I definitely prefer to place a part on a plan because it makes it much easier to use the assignment. Basically, for me, it is set up so that my drawing number, the project number, plus the position text are here at the bottom. That basically means you have to imagine. We are now simply going to look at this in HELiOS. At the very beginning, I created a project, the 4121, and my individual parts are stored here. As already mentioned, in HELiOS. I can view my drawings here regardless of whether I have a HiCAD or not. That is, it can be in the workshop. Whatever it is, I can view my drawings here. Here you can see the plan number 4121 for profile 100. The fifth is basically just the effect. Everyone then knows that the profile with the number 107 is the seventh on plan 100. For this, the HiCAD with HELiOS in combination has already generated a PDF for me. That means I also always have an automated PDF in the background here, which I can easily view, print, share, or whatever. And it is important that, for example, when I also create assembly drawings here, meaning I want to generate an assembly drawing from this, or even two, then it is the case that when the assembly drawing is generated according to my rule set, which I can adjust again, I can also say that if a position flag with the position number 100 is present, then I know where to find this part. This is also the reason why I definitely like to solve it in this manner. So, from my point of view, this traceability is much easier than having many parts on a plan. If I now only have small constructions with, I don't know, 40 or 50 different position numbers, then this is probably a bit exaggerated. In that case, I don't need such traceability. I hope you enjoyed it. This was just a small insight into how such a process could run. You can still quickly see my assemblies. My assembly drawings here. These are, of course, also stored here in HELiOS and are naturally updated with every change. That means this is now not just a derivation, but as you can see here in HELiOS itself, I also have my views available, which can then be viewed in the workshop and everywhere. 2001. I hope you enjoyed it, and I would be happy if you also subscribe to the channel.